Welcome back, guys. This is day 4, part 2, which will start on page 2. And really, we don't have a ton left as far as day 4 is concerned. Just a quick reminder, make sure you are getting completed our Delta math that was posted on Wednesday, so yesterday. That's going to be due kind of by the end of this week. So it is over one-step equations. So really, day 4 is going to be perfect for helping you get that done. But let's kind of get back to it, guys, because day 4 is all about one-step equations. And one of the reasons why I split this day up, is because the back half of this day has a bit tougher questions. And I wanted to talk to you guys a little bit about decimals, about fractions, and about mixed numbers. And that's really what problems 22 through 29 are all about. I want to say sorry ahead of time. I think I got some water on my page, so I'm going to do my best to work around that and try not to confuse you guys with that. But let's go ahead and take a look, guys, at maybe a problem that at first doesn't appear to be too scary, but when you really start to work it, you may get a little confused by the answer. So number 22. I know we see a minus sign there, but remember, guys, this is a -9. And how is that attached to the x? Through multiplication. And remember, when we're solving equations, give you a reminder, solving equations, let me bust out a different color here. We reverse operation. So we reverse operation it. So if this is -9 times x, guess what we're going to be doing? If it's being multiplied, we're going to divide. And we know our answer is going to be a negative because a positive divided by a negative will always be a negative. But here's the thing. What will our answer actually be? Now, I'm going to show you guys how we can find our answer as a fraction. And I think this is going to be pretty helpful to us because this answer as a decimal is an infinite decimal. It's what we call an irrational number. And I never really want you to put down decimals that go on forever because you can't represent that perfectly. Fractions are a perfect way to represent things. So let's look at 48 over -9 because I think that'll reduce. Let's think about some common factors that maybe go into both of these numbers. Well, 9 doesn't have too many factors. It's got 1, 9. 1 times 9 is 9. But what's the other way we can get 9 with multiplication? Oh, 3. Let's check and see if 3 can go into 48. 48 divided by 3 is, yeah. So why don't we divide both the top and the bottom by 3? And so that's the biggest like term they share. This is called simplifying your fraction. We talked about this back on day 1. And 48 divided by 3 is 16. -9 divided by 3, we know, we already have the negative there, is 3. So your answer would be x equals -16 over 3. Now this next one I would very much recommend a calculator. And if you have a graphing calculator like mine, I can show you how to do number 23. Check it out. We have a fraction 2/3 plus n. Well, remember, we're going to reverse operation anything that's attached to our variable. So if it's 2/3 plus n, and that's a positive 2/3 and not a negative, then we know we need to subtract 2/3. So 2/3 minus 2/3 subtracts out. Now -7/8 minus 2/3, that's where things get a little tricky. So let me show you. On these 84 calculators, or 83 if you have those, we use parentheses for fractions. So parentheses, -7 divided by 8, close parentheses. So there's our first fraction. Minus parentheses. Make sure you use the minus button, not the negative button. Minus button. Parentheses, 2 divided by 3. Oop, I accidentally threw an extra parenthesis in there, my bad. And then press enter. Now that is a hideous infinite decimal. That's not really going to help us any. But instead, if we go math, very first option, fraction, and then press the enter button again, oh, that's an exact answer right there. Negative 37 over 24. And guys, you have calculators on your computer that can do this exact same thing if you type it in carefully. So the last kind of problem, and the one that I know some of you guys either could be really good with, or some of you guys could be like, hey, this is something that I was never very good with, is mixed numbers. And I'll go ahead and tell you straight up, we don't really like dealing with mixed numbers once you get into high school. We like to represent those as what's called improper fractions. And improper fractions are like what we got for our answers on number 22 and number 23. These are fractions where the numerator is bigger than the denominator. It's a cleaner, simpler way to represent something like this rather than having three numbers laid out here just to represent one number. And for those of you who don't remember, let me remind you how we can turn a mixed number into a fraction, or into an improper fraction. Turn into improper fraction. Here's how we do it. So you see we have 1 1/4. Well, we're going to start by multiplying the whole number to the denominator. So first step, multiply the whole number to the denominator. So 1 times 4. 1 times 4 would be 4, but we don't stop there. Step 2. You then take that number you just got and you add that product to the numerator. So 1 times 4 is 4. 4 plus 1 is 5. And then step 3, you keep the denominator. So that denominator does not change. So if it was 4 before, it's 4 still. So we just turned 1 1/4 into 5/4. Well, guess what? I'm going to pause the video. See if you can turn 2 7/10 into an improper fraction. Go ahead. If you got 27 over 10, congratulations. That is what this will be, represented as an improper fraction. And so now we've just got two fractions that we can deal with. So if a plus 5/4 is happening, we need to reverse operation that. So subtract 5 over 4. Subtract it by itself to get it to subtract out. And then on your calculator, you can do 27 over 10 minus 5/4. And when you do that, we find out that A is going to equal one of two things. You could either write the decimal, 1.45, or you could go with the fraction, 29 over 20. Either one of those, guys, would be the correct answer there. Either one. I would accept either of those. And so I'm gonna shut my big mouth for a second, and I'm gonna let you guys try number 25 and number 26. And again, with numbers 25 and 26, I am fine with decimals on these because you're gonna see these are not infinite decimals. You're welcome to write these answers as fractions too. I'll be sure to give you both whenever you unpause the video. So go ahead and pause and try 25 and 26. Okay, 25 and 26. So number 25, we divide by -7. You could get -0.8 or -8 over 10 there. Actually, -8 over 10 would reduce down to -4 over 5. So my bad there. You would not want to leave that as -8 over 10. That would simplify. Sorry about that. And then number 26, you add 7.9 over, and I'm not going to make you write this one as a fraction because that is a nice simple decimal. A decimal plus a decimal gives you a decimal. So the last few, we're going to have some throwbacks right here, guys. Numbers 27 and 28. I'm going to give you a second. What are two ways we could solve number 27? What are two things we could do on this left side to get rid of that 5/3? Well, it's being multiplied to p, so we absolutely could divide by 5/3. Or couldn't we also, let me switch up colors here, couldn't we have also multiplied by the reciprocal? Multiply by 3/5, which would make you have to multiply by 3/5 on either side. You could have done it that way, guys. So on your calculator, you could either do 8/3 divided by 5/3, or really in your head or on your calculator, but by multiplying by the reciprocal, you can kind of do this in your head. You could multiply 8 times 3. 8, remember, we go straight across here. 8 times 3 and 3 times 5. So 24 over 15 equals P. And then some of you guys are probably thinking, well, is that the correct answer? Is that all that I would get here? Well, not quite, because 24 and 15 have something in common. You can divide them and see that, oh wait, 3 can go into both these, can't it? So you can simplify both those by their like term of 3, and you should end up with 8 over 3. So you could have done it that way, or you could have looked and said, okay, parentheses 8 divided by 3 divided by parentheses 5 divided by 3. Press enter. That's 1.6, which is also correct. Or you can change that math fraction to, hey, 8 over 3. Or I'm sorry, 8 over 3. Goodness. I made a couple mistakes today, guys, so don't feel bad if you make mistakes too. 8 over 5, I'm sorry. 8 over 5. 15 divided by 3 is not 3. It's 5. Either way, guys, those are two options you can choose there. Now, number 28, there is only one option here. G is being divided by 8, so we need to do the reverse operation. Let's multiply. If you want to destroy a fraction, you can multiply by its denominator, if the variable is the one on top. So we get G is going to equal, now remember, a whole number times a fraction. That whole number multiplies to the numerator. What's negative 3 times 8? Oh, that's negative 24 over 4. And you guys thinking that's going to reduce? Yes or no? Absolutely it will. 4 is going to go into both of these. So we can divide that by 4, divide that by 4, and we get negative 6 over 1, or what's that really, guys? Negative 6. Yep, negative 24 divided by 4, that's really negative 6. All right, last, in my opinion, the last tricky problem of the day is number 29. This is going to combine a little bit of everything here. We've got a mixed number. We've got m being divided by 8. So how about before we take care of the left side, before we get m and find out what it is, let's take care of this right side, because right now we've got ourselves a mixed number. And I'm going to give you guys a second. You can pause the video. See if you can turn 8 1/3 into an improper fraction. Go ahead. Okay, hopefully you had a chance to try that. 8 times 3 is 24. 24 plus 1, 25 over 3. And so now we're ready. If m is being divided by 8, let's multiply by 8. But we have to do that to the other side as well. A whole number times a fraction, that goes to the numerator. And 25 times 8, we know 25 times 4 is 100. So double that, 25 times 8 would be 200 over 3. And if you can believe it, 200 and 3 have no factors in common. In fact, 3 is a prime number. The only factors of 3 are 1 and 3. And 3 does not go into 200. So that fraction will not reduce. So to end today, guys, I'm going to give you a chance to think about number 30. Now, a quick reminder. We've done some word problems up here. In fact, we wrote down our 3 steps for most word problems. Identifying a variable, usually that comes in the last sentence, finding a total that they'll give you for the situation, and then plugging in your variable and any other number from the problem into the equation we create. So I want you guys to think about that on number 30, because we are going to write and solve an equation. So pause the video and let's read over number 30's prompt, and then you can read over part A. So the thing that stands out to me pretty immediately is on part A, they're asking us to find the average number of people the center is serving each hour. So I'm going to go with H, not P, because I want to keep the focus on the average number of people being planned to be fed each hour. So H is number of people, and don't just leave it there. It's the number of people fed per hour. It's an average, so the number of people that are being fed per hour. And so let's come up with our equation here, guys. So do they give us a total? Well, we are told that we have, 700 people. So we know that something's going to equal 700. Now, we also know that they're planning to feed those 700 people in 4 hours. So we know we have H. That's the number of people being fed per hour. How are we going to show that there are 4 hours here? Well, by taking H and multiplying 4 to it. So 4 hours times the number of people being fed per hour. And that should add up to be all 700 people. So we just came up with an equation right there, guys. And I bet some of you are thinking, oh, well, this is the easy part now. Now that we've got it, we can solve this no problem. And you're right. Divide by 4. And you end up getting that H is 175. So let's explain that. That means that every hour, 175 people are being fed. Now, I want you guys to try part B for me. This is going to be a little different. It's not really going to have anything to do with part A. So you're going to need to come up with a new variable and work from there. So you can pause the video, give it a shot. Okay, let's see if you guys were able to do this. So again, our variable comes from the end here. We're trying to find the number of people that remain to be fed. So I went with L as our variable. That's the number of people left to be fed. Well, how many total people do we know are at this community center? Well, if you remember, we're told that we have a total of 700 people. That's our total, same as the last one. But this is a different situation. How many people have already been fed? 270 people. So we know we've got 270 people that have been fed, plus what are we representing the number of people who have not been fed yet with? What variable did we say? L. So L is how many people still have to be fed. So the number of people fed plus the number of people not fed should equal all 700 people. And I'd say some of you guys can do the mental math, no problem. Subtract 270, and the number of people left to be fed is going to be 430 people. So guys, thank you so much for helping me finish up day 4. I know this was kind of a tougher day. Please make sure that you get that Delta Math knocked out from yesterday. It's due by the end of the week. If you have any questions, you guys know how to get in touch with me, and I'll be talking to you guys soon.